Hi, I'm Donna, an OpenSciEd teacher, and today we're going to be going into Lesson 5, part of the B.1 unit. The first time I taught this, it was chaos. I'm going to walk you through how I tackled this lesson in the future and turn chaos into a really fun opportunity and learning with the students. How we got here. So lesson 4, we figured out that rain is related to the wildebeest location, but there are other factors that limit wildebeest location, such as predators, fire, and then mud in the west. In this lesson, we're wondering how the amount of food regulates wildebeest survival and the Great Migration. Next, let's see the lesson at a glance and the sense-making loops. So this lesson is another investigation lesson. Love those. It will take 2 days. Material preparation is 20 minutes, so on the shorter side. It is a hands-on investigation and one of my students' favorites. It does require the devices and there are no additional videos. All right, these sense-making loops. We've got 2 sense-making loops, and they actually are broken up by the 2 different days. And we've got 4 key moments we'll be going into in this video. So sense-making loop 1, the students are going to be completing a kinesthetic model to simulate the Serengeti. And when they do that, they figure out that when the number of wildebeest is greater than the amount of grass, not all wildebeest survive. And this leads to cycles of ups and downs, increases and decreases, but centered around an average. And this leads the students to wonder, how do we see this in real populations? In sense-making loop 2, we're going to be analyzing wildebeest population data and trying to make sense of it. The students are going to figure out that there is a carrying capacity for wildebeest, and this number is increased by the wildebeest migration. Carrying capacity can also be connected to our regional ecosystems that we learned about in lesson 1. And this leads us to wonder what limiting factors can affect other systems. So what we figure out across this lesson, that the amount of food determines how many wildebeest can survive, and we can represent this with an algorithm, make an equation or a sentence to be able to express it. And we also identify that carrying capacity of wildebeest is high when there is a lack of competition for resources, and that wildebeest carrying capacity is increased by their migration because it's decreasing those limiting factors. So next, let's go ahead and get into the key moments. We've got part 3 as our first key moment, use a kinesthetic model. This is the part that was a little chaotic for me the first time I taught it, so I'm hoping that I'll go into some tips for you that you'll find useful. In this kinesthetic model, students are going to take on the role of wildebeest and grass, and they model generations of wildebeest and collect data. They're going to complete 10 to 15 rounds. I highly recommend use colored sheets of paper. I would use red and green, really bright paper, green for grass and red for wildebeest, and then it would make it easy for them to get new pieces of paper or for me to quickly give students paper depending on if they became grass or wildebeest in that new round. Having an observer to record the data is also very helpful because as a teacher, you're going to be running around and handing out cards to wildebeest and grass. And then next, in the next generation, to figure out how many new wildebeest there are, it's good to remember that 2 wildebeest will equal 1 offspring. And if the wildebeest does not find any grass, it dies and it becomes grass. That's when you're going to be exchanging those wildebeest colored cards for the grass ones. Part 4 is going to be making sense of the kinesthetic model. Students are going to create graphs of their class data. My students got really into this part because they had a lot of ownership of that data and they felt really confident with the graphs that they were making. It was great to see. They're going to find that there are cycles of ups and downs. Again, around that average, a plateau. I would sometimes talk to my students about the idea of kind of like a line of best fit when we see a bunch of dots on a graph. They're going to see that wildebeest population is limited by the amount of grass. And we're going to be asking the question, what does an increase or decrease on the graph mean? This really helps them make meaning of the data. When we see the slope going up, what was happening with the wildebeest and the grass? Part 8, we're going to analyze and make sense of wildebeest population data. This is where we introduce the real world data of wildebeest population. They're going to learn to calculate population's rate of change, and they're going to see that at different times, there were disease or drought also affecting wildebeest population. So it wasn't just dependent on grass. And lastly, in part 9, we're going to facilitate a building understanding discussion. And the students are going to conclude that when the population was limited by disease, food was not a limiting factor. But as soon as that vaccine came out to get rid of the disease, now food becomes a limiting factor. We're going to co-construct together a definition of carrying capacity, and we're going to see that migration increases carrying capacity due to food availability. That when they start to run out of food in one location, they can migrate to a new location to continue to support this very large population of wildebeest. This leads the students to start asking further questions and wondering, what are other ways migration helps survival, and how does this connect to our conservation profiles from the first lesson? So where do we go from here? We identified how limiting factors affect the carrying capacity of wildebeest and are wondering what other kinds of limiting factors affect systems and other key organisms. And in the next lesson, lesson 6, the students are going to be working on their first transfer task, which is a really awesome one. All right, we are almost through. We are at material management tips and tricks. So let's get into it. All right, rate of change. That can be a tricky part for students. I model a lot of this, the whole I do, we do, you do. So we'll do a couple examples of rate of change with smaller numbers, usually numbers that are no more than 50. And this usually helps them understand how to use the formula, and then they can apply it to those bigger wildebeest population numbers. And then I really like to put this rate of change formula up on the board. It's usually something that they're familiar with from their math class. And then I go through the investigate wildebeest population data in the Serengeti together, making sure to not just give the paper out and let them have at it, but taking our time to go through the questions together. Next, during the discussion, I like to ask follow-up questions and press students for their evidence. Why does the population not keep growing? What is that Goldilocks number or carrying capacity number for the wildebeest? And then at the end, I connect it back to their own conservation profiles, reminding them that, hey, you spent a lot of time learning about that conservation profile like the Everglades or HOH rainforest, and that's still important. And then we talk about maybe other examples of species that we know of that also migrate. My students like to bring up geese a lot. All right, for personal glossary management, so we're going to be co-constructing 2 words in this lesson, algorithm and carrying capacity. Materials that we're going to be using from previous lessons are those community agreements during our discussions. That's going to be referenced a lot. And with that, we have reached the end of the lesson video. So to summarize, make sure to go over the directions for the kinesthetic model. Clearly avoid that chaos that I had the first time that I taught this lesson. And don't forget to have fun with it. My students match my energy, and when that happens, it turns into a really memorable lesson for them and for me. In the next lesson video, I'll show you how to approach the first transfer task. Thank you, and you got this.